turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello and welcome to The Naked Scientists, the programme that brings you the latest breakthroughs in science, technology and medicine with me, Chris Smith.
And I'm James Titko. Coming up this week.
The AI-powered chatbot that can write science as convincingly as some scientists can. So what is ChatGPT? And are those who say it changes everything right?
The Naked Scientists podcast is powered by ukfast.co.uk.
Last month, we covered the new artificially intelligent chatbot taking the internet by storm. It's called ChatGPT 3. It's developed by OpenAI, and that's a subsidiary of Google. It takes prompts the user types in and responds with eerily lifelike and sophisticated prose. It's also capable of producing computer code.
Since it was let loose on the public, the potential of the software is starting to become apparent as millions of people play around with this really quite remarkable technology. In America, it's spooked them sufficiently that it's now been banned from some school networks to stop the kids there from getting the programme to do their homework for them.
To demonstrate its potential, and to find out a bit more about how chatbots got to the level they're at today, I thought I'd give ChatGPT a test drive before running its responses through some free online text-to-speech software to give it a voice. ChatGPT, what was the first chatbot?
The first chatbot, known as ELIZA, was created in the 1960s by Joseph Weizenbaum at MIT. It was designed to demonstrate the superficiality of communication between humans and computers.
What do you mean exactly by the superficiality of communication between humans and computers?
The program used simple pattern matching techniques to respond to users' inputs, which made it appear to be engaging in a meaningful conversation. However, in reality, the program was only able to respond in a superficial way, without any real understanding of the meaning behind the words being used.
So are you implying there that a modern chatbot, like ChatGPT, does have a real understanding of the meaning of the words used in a conversation like this?
As a modern language model, ChatGPT is capable of understanding the meaning of words and phrases, and can generate responses that are contextually appropriate. However, it is important to note that while ChatGPT can understand and respond to a wide range of inputs, it is still a machine and it does not possess the same level of understanding or consciousness as a human.
Well, I appreciate the honesty. What was the next development in chatbots after ELIZA?
After ELIZA, a number of other early chatbots were created, such as Parry and Jabberwocky. These chatbots improved upon ELIZA by incorporating more advanced natural language processing techniques and attempting to simulate more human-like conversation.
And then?
In the late 1990s and early 2000s, chatbots began to be used more widely in commercial applications, such as customer service and e-commerce. In recent years, with the advance of machine learning and deep learning techniques, chatbots have become more advanced and sophisticated. These chatbots, like ChatGPT, use neural networks to understand and generate text, and can handle more complex and open-ended conversations.
Well, yeah, I can see that. But how can I trust that anything you've said to this point is true?
I would advise you to cross-reference any information provided by me with other reliable sources to ensure the information's accuracy and validity. In addition, while I can provide answers to factual questions based on the information I was trained on, I am not able to provide personal opinions or make factual claims without evidence.
Interesting. So if I asked you what your favourite colour was, you'd say?
As a language model, I do not have personal preferences or feelings, and therefore, I do not have a favourite colour.
Ask a stupid question, get a stupid answer. Impressive though, isn't it, Chris?
Can I just be clear then? So you typed those things you were saying there, you typed that in, and then it generated text, which you fed into a speech synthesizer, which gave it that voice. How long did it take to come up with those responses? Was it almost instant?
Exactly that, almost instant. Once I'd got over the fact that it was a bit sad, I was sitting there chatting to my computer, I was stunned.
Yeah, I mean, hearing the reactions from you and then how it responded, and it didn't make any mistakes, it didn't go off in the wrong direction, that's verbatim what it produced.
Well, for brevity, the length of the responses was a bit longer, but Pretty much. I didn't change any of the grammar, any of the words around that. It was all exactly as it said it.
Well, Oxford University's Mike Waldridge, who spoke to us late last year when this story was first breaking and put us onto what was going on with ChatGPT well before the rest of the world actually started talking about that. He's back with us now and is going to give us more of a human touch, which James said he felt neglected in his interaction. So welcome, Mike, as the human sort of face of AI. Hopefully, as an AI specialist, you can help us understand a bit more about how this is all possible. First up, this all seems to have really taken off recently. It feels like there's a sort of watershed. Is that the case? And if so, what has provoked that?
So what's happened is that people have realized that scale matters in artificial intelligence. And what scale means for these systems is three things. Firstly, it means how big are your neural networks? Literally, the larger your neural networks are, the more elements that they have. That matters. The amount of training data that you use to train your system. I mean, modern artificial intelligence absolutely relies on training data. So that matters. And finally, the amount of compute effort that you're prepared to throw at training these programs, that matters. And so there was this move that started around about 5 years ago that just said, let's see how far we can take scale. Let's see how big our neural networks can get. Let's see how much data we can throw at these problems. And let's see how much compute resource we're prepared to use. And the first system, the ancestor of ChatGPT, was GPT-2, which I think appeared in 2018 or 19. Famously, it was supposedly so good that they were not prepared to release it to the public because this unprecedented power of AI was too much for us to handle. But what happened with GPT-3, the successor system, is basically it was an order of magnitude bigger, an order of magnitude more data, an order of magnitude more compute power. And that's the way things are going. There's been a race for scale. That's what we're seeing. We're seeing the benefits of that.
Well, Mike, I was just pressing James on, how quickly did it respond? Because you're used to your computer taking a while to load a game or something. And it's generating this output almost instantly, as though it were just a human spouting a result back at you. What sort of computing grunt have they got on the back end of that to make that possible?
Okay, so you've got to distinguish two different things. Firstly, there's building what's called training the model, throwing the data at it to train it so that it learns how to be able to respond. That takes AI supercomputers running for months. Computationally, one of the heaviest tasks that people are doing in computing now. There's a big concern here about the amount of CO2 that's being generated while you're doing that. We believe that GPT-3, which is the technology that underpins ChatGPT, used something like 24,000 GPUs, graphics processing units, and these are high-performance AI computers running for a number of months in order to be able to churn through that data. So that's the training part. But once you've got that, essentially you've got your neural network structures. Actually using them, the runtime, as we call it, actually what you were doing when you had your conversation, that's much cheaper, but you're not going to do it on a desktop computer. But you don't need anything like the scale. You don't need supercomputers to do that, but you still need a lot more than a desktop computer. And the reason is those neural networks are very, very big. GPT-3 is 175 billion parameters. Basically, these are the 175 billion numbers that make up that neural network.
That's what I wanted to ask you about, because now it's learned. What does it actually learn? What is sitting in that machine that means when James asks it for its opinion on colours and it says, well, I don't have one, how is it doing that?
So there's a long answer and a short answer, and the short answer
we've
is
got
that
about
we
a minute, so the short one.
The short answer is that we don't exactly know. The long answer is that basically what these things are doing is doing exactly the same as your smartphone does when it suggests a completion for you. So if you open up your smartphone and you start sending a text message to your partner, I start sending a text message to my wife saying I'm going to be, and it might suggest late or in the pub. How is it doing that? Because it's looked at all the text messages that I've ever sent, and it's seen that whenever I type I'm going to be, then the likeliest next thing is going to be late or in the pub. Okay, so GPT systems are doing the same thing, but on a vastly larger scale. The training data for them is not the text messages you've sent, It's every bit of digital text that they could get their hands on when they wanted to train it. They download the entire internet and they train it using all of that text to try to make the prediction of what would be the next likeliest thing in the sentence.
The problem is, Mike, that the internet is full of rubbish. There's tons and tons of unreliable data there. So how do you make sure that your system can sort wheat from chaff?
So you put your finger on one of the big issues with this technology at the moment. There is so much data that it can't all be checked by humans before it's fed to the machine. Again, the details are sketchy on exactly how it happened in these public systems, but there will be some screening, some probably automatic screening looking for toxic content. That will work to a certain extent, but it won't be reliable. It will get things wrong. It will allow through some things that really ideally we wouldn't allow. It will not be able to just check the veracity of an awful lot of stuff that it's fed. What we're getting out of this is some kind of aggregate picture. It's some kind of like an average of what it's seen out there on the internet. But to be honest, we need to do a ton more work to understand exactly what's going on there and exactly how we can deal with those issues. These are brand new tools that have landed on planet Earth, and we've got a lot more work to do to understand them.
What can we expect to see this do next?
So the things that they're phenomenally good at are things to do with text, and the kind of routine things that they're very good at doing, and I urge you to try it, is the following. Right, go to the BBC News website, cut and paste a story from the BBC News website and ask it to summarize it. And in my experience, it usually does a very, very good job of coming out with a summary. Ask for a 1-paragraph summary. Ask it to extract the top 3 bullet points from the news story, and it will do that. Take 2 news stories about the same thing and ask it to find what are the commonalities in the news story, what are the points of difference. It's, in my experience, also the technology is very, very good at that. It's not perfect. You have to check it. It comes out with falsehoods, but it's very good. Where are you going to see it? You're going to see it in your email system. So instead of showing you every email, you're going to get the top 3 bullet points from your email. I think that would be quite a useful thing to be able to do.
Mike, we're going to leave it there just for now. You're going to stay with us because we'll come back to you later in the programme.
Absolutely.
But that's Mike Waldridge from the University of Oxford. Thanks, Mike. You're listening to The Naked Scientist with me, Chris Smith, and with James Titko. And this week we're getting to grips with the technology that many are predicting will change the way that many of us work. That's called artificial intelligence, or AI, running large language models, the most sophisticated of which is now in the hands of anyone with a computer and currently freely available. It's called ChatGPT. And now that we understand a bit more about how it works, it's time to have a think about what sorts of immediate impacts might be felt by society as a result of its introduction, and how it could change things further in the future. Now, earlier on, we mentioned that some schools in America have already taken a very swift and hardline approach to students using ChatGPT to avoid having to finish their own assignments. They've banned the chatbot from computers that are hooked up to the school's network.
Vitomir Kovanovic is interested in this. He's a senior lecturer at the Centre for Change and Complexity in Learning at the University of South Australia. His background is in computer science and he specialises in learning analytics. He told me about how large language models could change education for the worse, but also for the better.
We had conversation with teachers in South Australia about what are the ways you can use this. And there are several really potentially beneficial ways, using it to very quickly generate a set of exam questions that haven't been used in the past. Previously, educators used question banks. I personally, with a colleague, we were just testing the system and we used it to generate the syllabus of the course. It actually produced very impressive syllabus. And then we said, how about you put a little bit more practical work in weeks 5 to 7 or whatever. And then the system generates another one. And that's how you have to use it. This kind of system will require still a lot of skills to use. Literally almost as, you hired a great composer and now you want him to compose something for you. You really need to be able to articulate what you want and be able, when it comes back with something, to say, this is not what I actually wanted. I wanted slightly more dynamic, or I wanted more darker tone, or what. You will need to understand and be able to communicate with the machine to achieve what you actually wanted to have.
It's interesting you framing it as the way it can be used to the benefit of education. I completely agree with those points. But I wonder if we could just rewind a bit and think again about how in the hands of the students, especially in the short term, because playing around with the technology myself, right, I can see how it would take a lot of the heavy lifting out of a task of an essay you've been set for homework. And especially if we continue to see improvements and students learn how to better use the software themselves, presumably this is a point of some concern.
Right away, it will really completely invalidate all the assessment we do, because let's be honest, a big part of the assessment is writing essays, long written responses and so on. But you can literally say, write me response to this question, pretending that you're a year 8 student, and he will simulate the stylistic complexity that would be expected of a year 8 or year 9 student, whatever. It can be used, and I'm pretty sure students are starting to use it. More of a bigger question, is this a good way to assess their learning?
Is it possible simply to just police this properly? Can we not just ban the websites on School Network to stop students being able to use it?
Well, on School Network, yes, things like that those are very easy to do. But the problem is these systems will become more and more common. And in a sense, why would you? The only reason to do it is to protect the existing assessment models. And we already know they're really not fit for purpose, so we want to change them.
I've heard ChatGPT be described before as like a calculator, but for essay writing and idea generation. Calculators, obviously, when they became inexpensive and widely available, didn't make maths a redundant subject. Is that a comparison or an analogy you like, or is ChatGPT even more powerful than, say, a calculator? Will it usher in even more dramatic change?
The comparison makes sense, but it's much more powerful. Grammar check would be something like calculator, something that does something very small, constrained, and it does help. Like writing a good essay with spell checker or without spell checker, it's not the same. But this is much more than that. It's almost like having professional mathematician sitting next to you. What's interesting is looking at the responses what people had in the 60s when calculators massively became available. That was the same discussion. Should we allow calculators? Shouldn't we allow them? But solving a big, complex mathematical problem requires you to use calculator 50 times. But how do you assemble the steps? This really critical thinking of solving mathematical problem, you still had to do it yourself. This system is far more powerful than that. I mean, you can still simulate at least some bit of this critical thinking. But if you want to really produce a good essay or good written response, you have to still intervene there. You're not just writing. Now you're being given by the computer a written response. And now you as a student, you need to evaluate, is it good enough for my task? You need to go back to the computer, give him more instructions, how to fix it and so on. So it will be far more back and forth.
The landscape just feels like it's changing so quickly. What sort of thing are we talking about how we change assessment? You mentioned the archaic way of doing it is by just saying no technology, but that seems like teachers will have a responsibility almost to integrate this. People will be using this in the workplace before too long.
It's still really open. We first need to see how people are going to be using this. How would somebody writing a script use this? What's the potential of this? Because this is a very, very fuzzy, different technology than others. Typically, when you develop a technology, you know what are these possibilities. We are not even sure what this technology can do. What we really want to focus on is, let's say you're given an essay on pros and cons of abortion laws or any complex social issue. Really what you're testing there is for critical thinking. Their ability to critically summarize different ideas, integrate them, compare them, see where there really is the difference. And you'll still have to do that. So the focus should be on that. It will shift a little bit of being focused on writing perfectly, because the machine can do that now. But we'll focus on your logic. What are you really writing there? I think in the future, we will see assessments becoming more complicated and more demanding.
Tough on kids growing up nowadays, eh? Vitomir Kovanovic from the University of South Wales in Australia there.
Now, talking about writing things, there was one study published this week that got our attention, and it's demonstrated that ChatGPT, this AI chatbot that we've been discussing this week, as well as being more than capable of generating homework that can't be distinguished from that of a real student, it can even pen scientific content, and at a standard that allows it to go undetected as computer made. in some cases anyway. Catherine Gow is a critical care physician. She's at Northwestern University and she has this side hustle in machine learning research. She saw what ChatGPT seemed to be capable of and she wondered how it would do at writing what we call science abstracts. These are the summaries of the results of science papers that are published in science journals. Well, it's fair to say it blew her expectations out of the water and it compelled her to then systematically work out just how indistinguishable it was from the science that's written by real scientists.
So one, we wondered if it would set off plagiarism detectors. The ChatGPT abstracts performed very well. They scored on average, 100% original. So really not using any plagiarism in the traditional sense.
What that's telling you is that ChatGPT is not just going to some source online and grabbing wholesale that abstract and regurgitating it at you. It's generating content that is not in existence anywhere else.
That's exactly right. So yeah, it's really sort of writing these abstracts from scratch. Another test that we looked at was whether or not it would score sort of high on a different type of detectors. There exist online these AI output detectors that you can run text through. And so the real abstracts all scored very, very low. Most of them scored 0.02% quote unquote fake, whereas the majority of the ChatGPT abstracts scored much higher, with a median score of 99.98% fake.
So a machine can spot another machine's work.
Yes, exactly.
Well.
Using the machines to detect the machines. That's very right.
What about, though, if you then thrust those results that it had generated in front of not a machine but people?
Like I said, I was really impressed at how good it is. So we gave collections of 25 abstracts that were a mixture of real abstracts and generated abstracts to different team members. So these are all members who are within our biomedical sciences lab. So they're used to engaging with science. We said, some of these are real, some of these are generated. Please give us a binary score of which one you think this is. And then you're also welcome to give us some notes to what made you think one way or the other. Even knowing that there are generated abstracts in this combined list, our human reviewers were only able to identify generated abstracts 68% of the time. And these were very, very suspicious, skeptical reviewers. They were so suspicious that they even thought 14% of the real abstracts were generated.
What about the quality of the content? Because you haven't said anything about that yet, whether or not when you looked at what the machine was saying, it was factually accurate.
At first I thought maybe it would provide some vague summary that was in the realm, but what we found is that in the generated abstracts, ChatGPT actually came up with completely sort of fabricated numbers for their results, basically reporting a whole study that was kind of just came out of the ether. So really surprising to me that it could quote unquote hallucinate these numbers and present them in a way that seemed still sort of factually sound enough that a reader might not be able to differentiate. If they were able to pick up 95% of the abstracts as generated, I think that would be kind of reassuring. 68% is not that good. And they even knew these abstracts were generated. So I think if someone came across the abstract sort of in the wild or, if they were reviewing stuff, they might not realize that, large language models have gotten so good at generating them and probably wouldn't think that it could be fake.
People are also raising concerns about, for instance, the use of tools like this to generate web page content. Because on the web, traffic is everything. Getting people to come to a resource, you throw adverts at them, you make revenue that way, you have a high footfall site because you have a huge site. Because at the end of the day, hitherto, creating content for your web page, that was the bottleneck because that was where a person had to be involved and that's where money had to be involved.
I think it gets to some very interesting questions about where do we go from here? In one way, could this be used in the hands of a responsible scientist to help take off the burden of writing, which sometimes can be, like you said, one of the bottlenecks of disseminating scientific work? Could it help improve equity across specifically scientists who have to write in a language that's not their own? What worries me also is what if this technology is used for evil, right? There are these organizations that exist out there called paper mills that are basically generating scientific content for profit. now with this technology that's so powerful, that's accessible and free, could this be used by these nefarious organizations to really spam science that's factually incorrect and dangerously convincing?
Well, could you go a step further and say, I've got a pharmaceutical company, it's not a very good one, it's deceitful, and it wants to push a product. So what it does is generate hundreds of papers supporting a drug that it's invented, saying how good it is, encouraging real organisations to buy in, either investors or organisations who want to buy the drug or the product, making money for that venture when in fact it's all founded on fake science.
The data that these models are trained on is detailed enough that it even sort of knows the right range of patient cohort sizes to present in the generated work. So for example, when we asked ChatGPT to write an abstract about study about diabetes, it included huge number of patients, because a lot of patients have diabetes, versus when we asked it to write an abstract about monkeypox, which is a much rarer, newer disease, it knew that the numbers needed to be much smaller. So certainly, I think in the hands of these more nefarious or ill-intended users, it could be a very dangerous technology.
It's worrying, isn't it? Good to know that that risk has been identified. Catherine Gow there from Northwestern.
Mike Waldridge from the University of Oxford is still with us. Mike, Catherine mentioned something about AI detection software and that being able to detect the phony science papers. Is that a foolproof model?
It's not foolproof. It's far from foolproof. I think there's an awful lot of work there to do. I think one of the interesting ideas that's out there that work's being done on now is the idea that OpenAI can insert into the text that ChatGPT generates essentially a digital watermark, something which allows you to be able to analyze a piece of text and tell that it was actually produced by a system like ChatGPT. So we don't have that yet, but I think that's a very interesting direction. But at the moment, I think us educators have got a headache right now to be able to identify this. Us researchers, when we're looking at abstracts and research papers, it's going to be a challenge in the years ahead. And the real big worry for me is that peer review, which is the process that we use to evaluate scientific contributions, is already under strain. But systems like this might be used just to swamp and overwhelm peer review, where you're just getting an awful lot of very plausible looking reports and papers that are being produced by systems like that. So there's a lot of concern around those issues right now.
And if I could ask you to speak briefly, we haven't had a chance to even talk about the potential for ChatGPT to produce computer code. What are the possibilities there?
As I already mentioned, essentially the way that these programs are trained is you just download the entire World Wide Web and you train it on that. And in amongst all of that, there's a huge amount of computer code. So the site that we like to use to upload our code and prove how clever we are is called GitHub. And if you go to GitHub, there's tens of thousands, probably millions of computer programs that have been uploaded. You can analyze those programs, and computer programming languages like Python and C, the languages that we use to write computer programs, are much simpler to understand than human languages like English are. They're much simpler. They're very, very well defined and actually incredibly simple languages to analyze. So it's no surprise that systems like ChatGPT should be quite good at being able to analyze and produce computer code. So it's no surprise that programs like ChatGPT, which were designed to be able to analyze and understand and produce complex human languages, can cope with much simpler computer programs. Where that technology is up to right now is being able to produce relatively short programs, a few tens of lines of computer code, which are kind of very often the useful little tools and utilities that we might use in our computer programming. I don't envisage them being able to produce Microsoft Windows or Microsoft Excel anytime soon. But there are some really fascinating applications of this. One of the most interesting is that ChatGPT can't do arithmetic and it can't do mathematics because that's not what it was designed for. But it can write computer programs that can do mathematics and arithmetic. In other words, there's a problem that it can't solve itself, but it can write a computer program to solve that problem. And at this point, I just wish Alan Turing was alive to see this technology. He would love to see this. This would really tickle, I think, his fancy. It's absolutely fascinating from the point of view of computer science.
Unbelievable, isn't it? One other thing, Mike, while we've got you, that I wanted to ask, because another artificial intelligence technology that seems to be getting better with each passing day is deepfakes. And the mind boggles at the possibilities of when we're able to somehow integrate the sophisticated level of ChatGPT with the deepfake software out there as well. Are we at a stage where we almost need to question anything we see online now?
I think absolutely. I mean, I think certainly we're at the point now where you can't trust text that you find on social media and so on. There's just no reason to do it. This is why it's incredibly important to have provenance, to know where this text came from with confidence. But computer generated images and videos are not long behind. I mean, this is now very much within sight.
Thanks very much for being with us, Mike. We'll have to leave it there. That's Mike Wooldridge from the University of Oxford.
And that's it for this week. But do join us next time when we are looking skywards towards the machines that give us GPS, climate data, and images of the cosmos. We're, of course, talking about satellites. With outer space fast becoming the new frontier to conquer, we're looking at how the next industrial revolution will be in space and how we can protect our probes and satellites from the biggest threat confronting them, and that looks like it's our own sun. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thank you for listening, and until next time, goodbye.